Hi guys, we are going to continue talking about quadratic graphs. I just have a couple of examples for you to show you how the A and C values will alter your quadratic. Okay, right here in blue on this graph, add arrows to it, this is that basic quadratic function that I was talking about yesterday. This is the graph of y equals x squared. Okay, so what I'm going to do is look at two graphs and how they are different from that parent function or that basic quadratic. So right here, first one is y equals 1/3 x squared. So what I'm going to do is make a table of values right here. Y equals 1/3 x squared. I'm going to plug that into my calculator and hit my table of values so I can pull out some points. Now, when I look at this, there's no b value. So I know that the axis of symmetry is 0. So that's going to be in the middle of my table. All right, that's going to be my turning point. So when x is 0, my y is also 0. Okay, so now I'm going to pick a couple points to the right and left of that point. And when I'm looking at my table, I'm going to take the points -3 and -6, 3, and 6. And the reason that is because if your x or if your y values are going by ones, you're going to notice that like -1 is a fraction, -2 is a fraction. So I'm just picking these because they end up being whole numbers, 3 and 12, and it's just going to make it easier for me to graph it. Okay, so now I'm going to plot these points. So 0, 0, 3, 3, and then I know -3 was 3 also, and 6 and 12 is going to be probably right about here, and -6 is right about there. So graph goes up like this, goes up like this, and this is y equals 1/3 x squared. All right, now I am going to plug in y equals 3x squared into my graph. Y equals 3x squared into my graph and fill in a table of values and see what happens this time. Again, I know that the axis of symmetry is 0 because there's no b value, so I'm going to put that in the center of my table, and that point is going to be 0, 0, and then I'm just going to pick again some values to the right and left of it. This time I'm going to do -1, -2, 1, and 2. So when x is -1, y is 3. When it's -2, it's 12. When it is 1, it's 3, and when it's 2, it's also 12. Okay, so I'm going to graph these points. So 0, 0. I have 1, 3, -1, 3. 2, 12 will be about here, and -2, 12 will be about here. So it curves up like this. So I get y equals 3x squared. All right, so now taking a look at what has happened. Remember, in blue is our parent function of x squared, and then we had the equation y equals 1/3 x squared, and then also in purple we had y equals 3x squared. So in this example, we're looking at, well, how did that a value affect the graph of the parent function? So what happened? And what you should notice is that when we did our first graph, y equals 1/3 x, 1/3 made the graph get wider, okay? It made it kind of flattened the original graph out, or it compressed it down towards the x-axis. When we look at y equals 3x, the number 3, what it did is it actually made the graph skinnier, or it took all of these points and it like squeezed it together. It is stretching it up, making it skinnier away from the x-axis. Okay, so some points to remember from this is what I just said. And we're looking at the absolute value, it can be positive or negative. Just think about the absolute value is greater than 1. So that was like the y equals 3x. What happened is we have what they call a vertical stretch, and it's going to become narrower than parent function. If we look at the other graph of y equals 1/3 x, think about the absolute value of that. If it's less than 1, okay, 1/3 less than 1, what happens is it's going to kind of flatten it down, or it's going to compress it down, and it makes it look wider than the parent function. So we call this a vertical compression. Okay, and this is going to look wider. Okay, so when you're looking at the initial equations, just know that if the a value is less than 1, your graph is going to get wider. And if the a value is greater than 1, your graph should get skinnier. Everything should be stretched up. Okay. I'm going to skip over. Oh, we could do this real quick. What is the order from widest to narrowest of the graphs of the quadratic functions? Use the graph if necessary. I'm not going to use the graph because I'm just going to go based on what I had just talked about. I know this is my parent function right here. I know that if the a value is greater than 1, it's going to be, or the absolute value is greater than 1, it's going to be narrow. So I know that this graph is going to be narrower than than C. And then if I look at letter A, this one, the a value is less than 1. So I know that this graph is a vertical compression of the parent function. So this is going to be wider. So if I'm going to order this from widest to narrowest, this is going to be the widest graph, then my parent function, and then negative 4x squared. Okay, and if you get confused on a question like that, put all 3 graphs in the calculator, and then you'd be able to see from the graph the order from widest to narrowest. Okay, now looking at what the C value does. Okay, so again, in blue is the parent function, y equals x squared. Okay, so this time I'm going to graph y equals x squared plus 3 and see what happens. Okay, for this one, again, my b value, there is no b value, there's no x term, so I know that that axis of symmetry is 0. So I'm going to start with 0, x equals 0 in the middle of my table. I'm going to pick some values to the right and left of that. And now I'm going to plug it in my calculator and see what the y values are. So when x is 0, y is 3, negative 1 is 4, negative 2 is 7, 1 is 4, and 2 is 7. Okay, I'm going to plot these points. Let's see, 1, 4, 1 negative, or 1 negative 1, 4, and 2, 7, so negative 2, 7. Oh, whoops. I graphed that first point wrong. Right here. 0, 3. So this is going to come up and out. This is going to come up and out. And this is y equals x squared plus 3. Okay, what you're going to notice is the curve is going up at like the same rate, or the curve looks the same. The only thing that's different is now it is shifted up 3 units, okay? Because remember what I said yesterday, this value, the C value, is where it intersects the y-axis. So it's saying that we're taking that parent function and we are just now shifting it up 3 units, because we're going to start where y equals 3 versus starting where y equals 0. Okay? So we could say If C is greater than 0, you're going to shift up, because that's going to be like if you're adding, 1, adding 2, adding 3, it's going to be adding a positive number. So you're always going to shift up however many units C is, because you have to go to that value on the y-axis. Okay? If C is less than 0, so that means it would be like x squared minus 3, you're going to start at a negative y value. So you're actually shifting down C units. Okay, they call this a vertical translation. You're just shifting that graph up or down. Okay. Up here it says, what are the domain and the range? So the domain and the range of y equals x squared, your domain, you're still covering all of your x values, because the graph is going to continue to go into the negatives as the curve goes up, and it's going to continue to go into the positives as the curve goes up. So the domain is negative infinity to positive infinity. The range, the lowest y value or the smallest y value that's used is 0. And then it actually includes 0. And then it will go off into positive infinity. For the equation y equals x squared plus 3, the domain, it's still negative infinity. It's still negative infinity to positive infinity. But the range is going to be different this time, because now the lowest y value is 3, and it will go off into infinity. Because of that shift, because of that plus 3, that's what's changing the range for this problem. Okay, I'm going to take a look at 2 word problems. When you're dealing with word problems in quadratics, you have to think about what the domain you should use to make the problem make sense, okay? For these 2 examples, this is talking about an object that is falling, and speed continues to increase, okay? So we're going to start at a certain height above the ground, and then as the object is falling, it's going to get faster and faster and faster as it falls. This is the formula that we can use to figure out how long it takes this object to fall. It says h is the height in feet, so that's the height that the object will be at. T is the seconds, so that's after how many seconds it has been falling. And C is that initial height. Okay, initial height means like, where did you start? Where did you drop that object from? All right, so if we look at number 1, it says an acorn drops from a tree branch 20 feet above the ground. So we are going to have our function. Here's the height equals negative 16 times squared plus 20. Now see how C became positive 20? Because we are dropping it from 20 feet above the ground. All right, it gives a height of the acorn in feet after t seconds. So what is the graph of this quadratic function? About what time does the acorn hit the ground? What are a reasonable domain and range for this function? All right, so the first thing I'm going to do is I am going to type this into my calculator to get some values. Now, when it asks what's the reasonable domain and range, so along the x-axis, this is going to be talking about time, okay? And this is seconds, if I'm dealing with time, I'm not going into the negatives, okay? I can't be dropping an acorn for negative 3 seconds. So when I'm thinking about my domain, I know that I can include 0. I mean, that's where I'm going to start. That's when I initially hit the stopwatch. And I'm going to leave it blank. I'm going to see, okay, well, how long is it going to take this acorn to drop? Okay, what would be reasonable ending time for my domain? Okay. So let's start there. When I put this in my calculator, I'm going to start where x is 0. And it says y is 20. And that makes sense because if 0 time has gone by, I am still holding that acorn 20 feet, or it's still on the branch 20 feet above the ground. So let's see, I'm going to go by 2's. And this is going to be height in feet. All right, so I'm going to start at 0, 20. All right, the next point, it says 1, 4. So let's have these go by, spread this out a little bit. Okay, so 1, positive 4. And then it says 2, negative 44. So 2, negative 44 is going to be all the way down here somewhere. All right, so my curve is just coming down like that. Okay, now once I get to where I hit the x-axis, oops, I didn't want the whole thing to go away. Once I get to where I hit the x-axis, it's dropped. It's hit the ground. It's not going to go, negative into the ground. So I'm going to be done. Now, on my calculator, when x is 2, it says negative 44. When x is 1, it's 4. So I don't exactly know when it actually hits the ground because I know at 1 second, it's 4 feet above the ground. I don't know the exact number when it actually hit the ground. So this is where you can go into your graph like we did yesterday. If you go into your graph and then you hit second trace, so you're going to go to that calculate button. If we go to that 0 button again, this right here, remember 0 is when it crosses the x-axis, it's when that y value is 0. So if you click on that button and you calculate, and hit enter, it says that at approximately 1.118034 seconds, it will hit the ground. Okay. So our range was our y values. Our range, we are going to start, or the lowest we can go is 0 feet because we're not going to go below the ground. And it's going to go up to 20 feet. Okay, so these would be reasonable domain and range for the function. And then it says about what time does the acorn hit the ground. So this right here was when it hit the ground. So we could say it hits the ground at about 1.118034 seconds. Okay. Okay, let's do one more quickly. It says, suppose that acorn, so this one's the same thing, actually. I'm going to skip over this. If you have any questions and you want me to go through this problem, feel free to email me and I can do that for you. All right, I hope this helps, and I will post the homework along with this video for you.